And you're here back for another week with Mr. Betcher, Ms. Berlin, and myself for Breaking Down Security. I am Brian Brake, of course.
Hi. How's things?
I don't know. Is Mr. Betcher the strong silent type again? Get out your bingo cards. It's going to be a good one this week, kids. I know. It threw you off. The beginning threw you off there a little bit. So, Mr. Betcher, how are you doing, sir?
Doing good.
Yeah?
I got plenty of sleep this weekend, so I'm ready for the week.
Excellent. Excellent.
I got none, so I'm just going to sleep all week.
Wait, what?
Yeah, we're kind of opposite that way.
Yeah.
I only get like 5 hours of sleep during the week, and then I try to make it up on the weekend. I don't know if that's healthy or what, but I do make it up.
Well, by Thursday or Friday, you're probably dragging ass, I would imagine. So
I am, yeah.
Right.
But, hey.
Right. Okay. So it's the end of the month. What are we expecting from the BDIR show that's coming up this month? Who are we going to talk to? What are we going to talk about? You and Mr. Goff.
Yeah, we've got a really awesome guest lined up. We're going to talk about incident response and team management, things like that. How do you implement an incident response program and all that? And we'll have an expert on to talk about how you do that.
Excellent.
Or improve upon what you have.
You're not going to jinx it by putting the expert's name out there?
No.
Why not?
And if they don't show up, we'll just do it ourselves then.
Oh, okay.
I think we know a little bit about IR, so we'll be able to wing it. But no, I am expecting this person to show, and we'll have a great episode.
Excellent.
Lined up.
Excellent. All right. So I want to go ahead and get started because I have a feeling this is going to be a long show because we have a lot to talk about.
Whoa.
What was that?
I didn't do it.
Are you sure?
That was our guest.
Oh, okay. Boy, you just throwing him under the bus. Here it is. Oh, thump, just right under the bus. Yeah, we do have a guest this week. He was on about a month ago talking about retooling with the what was it, Lord Dr. Mr. Snooze or whatever. He has a whole bunch of titles now these days, I guess.
Lord.
Yeah, Lord Dr. Mr. Snooze. So we have Jay Beale back on. We actually wanted to talk to him about the stuff we're talking to him tonight about, but it ran long, of course, with all the retooling and the very interesting stuff, which actually helped me when I was working to get my new job because it kind of gave me the confidence to go ahead and do that. So we brought Mr. Beale back to talk about container security and what containers are. Maybe talk about some S3 stuff if we've got the time. So Jay, welcome back to the show.
Oh, thanks for having me. I'm happy to be back.
Okay.
It was really recent.
Yeah, it was about a little over a month ago, but that's okay because we had suggested you come back and talk about the container stuff. So,
well, in my daughter's lifespan, that's half of her current lifespan has gone by in that time.
How many episodes of Little Einsteins is that?
We haven't gotten to Little Einstein yet.
Oh, really? Okay. Yeah.
No. There's I don't know.
Believe me, there's plenty of time.
Yeah.
Okay.
Yeah, they rotate every 5 years because they don't need to make new episodes after 5 years because they just rotate them over and over again. But they're a really great show. I love them.
Yeah, I could sing that song.
Yep.
At this stage, most of her entertainment, most of Sophia's entertainment is us singing. So,
right on.
If you've ever been to karaoke with me, you should be wincing when I tell you that entertainment is us singing because, man, am I not a great singer.
You teach her the classics?
What's that?
You teach her the classics?
Yeah. I mean, we're getting through all the nursery rhymes, and we haven't gotten
back
yet. But
Yeah, baby got back. Yeah. You do.
Obviously, Nirvana would be good.
Smells Like Teen Spirit. Yeah.
Smells Like Teen Spirit. That's. I mean, she doesn't understand.
Let the bodies hit the floor.
Wow.
I don't know. Smells Like Teen Spirit. I kind of love just the way words are strung together without any need for coherent meaning.
Yeah.
And I kind of figure at this age she may not actually realize that that's going on. It'll just. So I don't know if that means that's just fine, no big deal, or if I made one of her songs Smells Like Teen Spirit, if I would screw up her language acquisition badly.
Well, should be talking like yes, daddy. Yeah, no. Yeah, get her on the Radiohead stuff. You know, get her on some early Radiohead as well. You know, maybe yeah, gotta love that.
I think they might be giants. I want to definitely get on that. And then they got into making children's music eventually.
Yep. Yes, they did.
But even their adult stuff was pretty sing songy. It's pretty
it's
easy
catchy. Yeah. Bare Naked Ladies came out with the kids album, I believe, as well.
No way. Nice.
Bare Naked Ladies, yeah. So, yeah. Well, all right. So for those parents out there who are like, yes, this is all great. I've went through this, we want to hear about container security. Jay, the reason we had you on is because you're somewhat knowledgeable about this. You're actually doing a class at Black Hat.
I am. I have a class that I teach at Black Hat every year, and sometimes I teach at other conferences or do private trainings with it. But yeah, I do a class on Linux security, and it has changed. I've been teaching it since maybe 2001, and so it's changed massively over the course of that time. We've had for a while. I'd added Solaris to it and other Unixes that basically, for all intents and purposes, no longer exist.
Right.
But that means on the flip side that at this point we're talking in the class about containers, and this year that means we're adding some. Last year the last couple of years we've done some Docker stuff, and now this year we're adding in Kubernetes.
Okay.
And then in a future year I think the class will end up splitting into two halves into two classes, where one class just goes more heavily into DevOps, into like DevOps security in general. And so we'll talk containers a ton, and Kubernetes will get a heck of a lot more time, which it could certainly use.
Right.
It's, yeah.
Okay.
I'm even I've been teaching this class at Black Hat, and I have a blast. We have a great time every year. It forces me to keep learning. I got into the Linux lockdown stuff back in like 2000 or 1999, making a tool called Bastille Linux, and I've written some books and whatnot. But yeah, it's teaching. Having to teach a class means like having to stay not just current, but like get ahead. And that's been wonderful, because it means no matter what I'm doing, what I'm doing at work, if I'm doing a lot of Linux at work or not that much Linux at work, I still have to stay on the edge,
right.
So I can teach it, and I really love it. So.
Very cool. So
I thought you were going to say, when you said it changed so much, I thought you were going to say it changed my life. I mean, has it really? I mean,
I don't know.
Some eye-opening moments.
Different evolutions.
Nice.
No. I don't know. I think InfoSec has definitely changed my life. I bet it's changed each of yours. We get to do like this totally fascinating field, and the size, the sheer amount of things that there are to know mean that no matter what you get really good at, you always feel you've always got imposter syndrome, because there are all these things that you're like, I really should know how to do that, but I should have experienced doing that. And you're like, I don't touch that. I'm finally getting to the point where I'm more comfortable specializing than I ever was before, and just being like, you know what, we have a bunch of people in Guardians who do radio hacking, and we have a bunch of people who do software-defined radio, and we have a bunch of people in Guardians who like take apart smart meters and do all kinds of hardware hacking attack work, and a whole bunch of industrial control system stuff. And I have virtually no expertise in any of it. And I used to feel bad about it. And I'm finally like, no, okay, I have to specialize. There's just no way, if I don't get down to just like, okay, I'm going to keep myself current in 6 specialties instead of the 20 or 30 that our field has.
Right.
I don't know if do you guys feel the same way? Do you end up just being like, darn it, I should stay current in that, but if I think of all those shoulds, all the should things I should stay current in, it's enormous, and it's not doable by any one human.
Yeah. No, it's definitely
all the time.
all the time. Exactly. Yeah. And so, what we're trying to do with the show is we kind of try to stay a little current about a little bit of everything. So, yeah. So, containers, so people who maybe are new to the whole idea of containers, or their CIO saw this at RSA, and it's all about the containers and the futures. How is it so much different than a VM?
It's a good question. So containers, so virtual machines, on the one hand, I think we're all really, really used to that. It's the virtual machine basically tries to emulate a full set of hardware. So, in your VM, you can install any operating system that would run on, say, x86 hardware. That would, when you're dealing with containers, it's nothing like that. With a container, you have a virtual machine, or you're on hardware, and that thing provides the operating system. And the operating system basically has to be Linux. I mean, there's Docker for Windows, and I think that's running a Windows container. So let's just stick on Linux containers. Mm-hmm. So you run a Linux distribution. It's running a kernel. It's got a bunch of services, and you interact with that kernel and tell that kernel, hey, I'd like you to put this program or these programs into a container. And you can do that with Docker, or you can do it with just systemd. With systemd commands, you can do it with a bunch of other things they call container runtimes. But what that does is those runtimes just instruct the kernel to give those processes, like it's called, the concept is namespaces, to basically give the processes that are in that container a different view of the file system. That's like the mount namespace, a different view of the network and of what its hostname is. So that's the network and the hostname namespace. A different idea of the process ID tree. Mm-hmm. So you'll have a process ID in the container that's process ID 1, and it might be the program you're trying to contain, or it might be a shell or whatever. It won't be the one that's process ID 1 on the main system. So the container, the cool thing about that is you don't have to start up a container. You don't have to boot a whole operating system. You just say, hey, operating system's already running. Hey, kernel, could you just, do me a favor, start this program and stick it, and give it a bunch of different settings, give it a different view of the file system, and give it a different IP address and a different routing table, and heck, different users in a different IPC space. And so to the program that's in there, it's like, oh, cool, I've got this computer all to myself. And it feels like it's got the computer all to itself. But really, it's just a program running on that same operating system. It's really, really lightweight. I mean, I do a thing when I teach this where I start up 20 or 50 containers real quick. Just, each of them just start up and like, okay, now we got 50 containers running. And that took us a few seconds. It wasn't like booting an operating system.
Yeah. The
cool thing is that means that, you can do things, you can do this with much, it's just nowhere near resource intensive. So one of the things I like to do is I've got a Raspberry Pi and I'll run containers on it. I'll run 4 containers on it. And it'll be fine. If I were to run a 5th though, it's like, not enough cores, this isn't, the Pi is only so powerful, but but you couldn't run virtual machines on a Pi. That would be insane.
Right.
So that's if that answers your question, that's kind of why containers at all. It's that they're lightweight as hell, and they let you do some cool things. I think really in a lot of ways, the big things, the big reasons people get excited about containers, like I got into them because I thought of them as another kind of containment security that I could use in Linux lockdown. But the like kind of business cases for containers are partly, well, what if I have a bare metal system, or what if I have virtual machines and I want to be able to provision work onto them? I want to put programs on them, have those programs run, have those programs come off, and put new programs on and make that really fast and really easy and get as many as I want in one place. And heck, if you're Amazon or you're Red Hat or, you're a cloud provider, you're saying how many different customers can I get onto one piece of hardware, onto one racked server. and containers let you put a heck of a lot more than VMs.
Sure. Yeah, the AWS instances, if you've got an M2 large or something like that, and it's sitting idle 99% of the time, that's wasted resources. So if you're not using, if you're not running those hot where it's like 80-90% utilization the whole time, you're just wasting money. For the 5% of the time that you might actually use it for greater than 20%.
Yeah.
Yeah.
So a lot of people will basically take those instances. There are a lot of people who will take Docker or Kubernetes or other things that or other systems or other orchestration systems, and they'll get a bunch of AWS hosts and they'll orchestrate and they'll basically trying to put work on them. I was trying to explain to one of the folks at Guardians the other day. He and I were talking, and and he said, "So what's Kubernetes for? Like, I get Docker, like I've been playing with Docker, but now now I want to get into Kubernetes. What is it? What's it for?" And I said, "Well, you kind of got to think about where it came from. It came from Google, and Google, in running Gmail or all the other kinds of software as a service things that we use. Google's like, okay, I have lots of things that I need to do. Suppose I have a unit of work. Maybe that unit of work is show Jay his inbox right now. Just give him one view of the inbox and close the, and be done with that and move on. Or maybe that unit of work is I need to do some indexing across an email that just came in or what have you. They've got a ton of those things. So, if you can imagine yourself with 4 virtual machines and you've got, and you have 8 things to do, you could be like, okay, and those 4 virtual machines are already doing some things. And so you're like, where do I put each of these 8? You take one and you're like, okay, I'll put this one on the least loaded virtual machine. Okay, now I've got the next thing to put in. Oh, I'll put it on the least loaded virtual machine. Oh my God, this second one is much, much bigger than the first. I should have run that on the other one. And you're like, wow, okay, how do you decide to do that? And now what if you've got what if instead of having 8 programs to go in place on machines that already have things going on in them, and you have to figure out which ones, how it would fit the best with the resource constraints you have on each machine. What if you had 8,000 per second that you had to, programs that you needed to be able to stage, to go and stage them and then move on to the next 8,000 that are coming in. I don't know exactly what the number is, but Kubernetes came from this project at Google called Borg, and that's exactly what it does. You tell Borg, hey, I need say 20 machines to run this thing, and I need it to be fault tolerant, and it's not going to take very long. How do I do that? And that's what Borg did for them. So this is kind of basically what Kubernetes is about. Sounds
like it's like an automation workflow for scaling up operations.
It is, and it's a way of moving work around, doing so expecting that machines will die, expecting that hardware failures will happen, that operating system failures will happen, and just making it really, really easy. That like, okay, if you give me something to run, I won't run it on one machine. I'm going to go and make sure that it goes on at least 3 hosts, and if one fails, then I'll stand up another one. And if 2 fail, I'll stand up 2 more. And like all of that will be well managed, and the load balancing will be well managed. And then finally, that the thing that, if you're thinking to yourself as you're listening to us that that's not a problem you have, we could kind of just scale back to Docker, to why Docker's made containers really, really popular. The big one for Docker is just kind of very similar to what Vagrant does, but taking it to the next level. In essence, you've got a developer, and he's told, I have a bug, and he's told by somebody, we have a bug, and we need to fix it. And it's like, the code works fine on my system. How many times, if you've been in a development or administration environment, have you heard, works fine for me? And that kind of seems like it ends the conversation. You're like, darn it. Okay, we can't do anything about it because it works fine. I can't replicate it. And the trick Vagrant came about as a way of allowing a developer to stand up in an environment, a virtual machine that was just like everybody else's, and have that be, have that not take too long. When you go to Docker and containers, you have oh my God, the state of the operating system that you have in production is the same as you have in test, is the same as you have in dev, and that doesn't take any discipline whatsoever because the containers facilitating that. You
Right.
distribute the software with the entire operating system you want it to run on, and that's really, really lightweight.
Yeah. So
I took parallel programming in college, and you had to be really aware of how your program could be distributed between all the different processors. Is that the same thing when you program with Kubernetes?
Yeah, that's a good question. So and I want to stress that all of this stuff is relatively new in its uptake. It's relatively new in getting so popular. And so what you're supposed to do is advancing faster than what people's practices are.
mhm.
But yeah, part of the idea when you're running things in Kubernetes, when you're running things in containers, the design pattern they're trying to get the developers towards are called microservices, where your application, where your server application is broken up into more pieces. This is very much like the Linux way of doing anything. It's broken up into this way the Linux command line works. It's not how the server programs have usually worked, but you break up into lots of services. If you've run postfix, that's what postfix does. Instead of running one program, you run 12, and they interact with each other. And the positive of there are a bunch of good reasons for doing it, but one of the good reasons is it means you can scale one part of the program a lot more than the others. You end up having to be more aware. You end up kind of having to be more aware, but the idea is if you get all of these parts of the program into separate programs, then you're not trying to handling the what's the word I'm looking for? Handling the concurrency isn't so rough, because the part of the program that would rely on another part of the program to do something isn't like, oh, I'm going to go and look in I placed it into memory, and now I'm going to wait for the other thing to read it out of the same memory and so on. You're just saying, no, screw it. We're gonna have this happening across the network, and across the network might be on the same host, but it might not be.
Right. So
Right.
you mentioned isolating programs. Amanda had a question before the podcast about that.
So like my first, what I thought was container type interaction was with VMware's ThinApp. And it was a while ago now, probably, 6-7 years, whenever that first came out, I think. So I was wondering what the difference between that and containers is, and then also is there a difference between any of that and sandboxing?
Sure. So I didn't actually get familiar with ThinApp. So the nice thing is we're all sitting at computers, and so I got the chance to Google. And it's sure, reading about ThinApp, I'm guessing that ThinApp was probably using virtual machines. Might not have been, but it definitely has some of the same purpose. And I'm reading this, and it's like, hey, migrate a legacy web app. Make the operating system and the application a little more independent. And you're like, oh, okay, cool. And then package it up in this way. And I mean, Docker gets its name from one of those big values that seems like ThinApp's describing here, which is this idea that instead of shipping a program and saying you have to have these libraries, you ship you don't really ship a container, you ship a container image. But a Docker container, like in shipping, in transoceanic and
Right.
And roadway shipping, that you're shipping this thing. So yeah, it's probably similar. That said, I don't know. I haven't looked at ThinApp any more than just that quick Google search.
Yeah, I just remember us using it for we had for example, we had several users that had to have different versions of Java for whatever.
Yeah.
You were able to do that and still control everything on the endpoint by having one kind of like image of an application and pushing that out to machines.
That's really cool.
Yeah.
That's very similar to what Docker is doing. It's sure making that question of, like if you've ever developed in Python or Ruby, it's really a pain in the butt. And it's such a pain in the butt that like different things are with different versions of different libraries, so much that both of those, Python with things like virtual env, and Ruby with, the way they do their gem files. You have this idea of saying like, I need these versions and when this program runs, it should run with those versions of the libraries and so on.
Yep.
And, and it sounds like ThinApp and Docker, both, could take, or just in general, like shipping software by way of containers is aimed at exactly that. Like, okay, this server, we have an operating system here, and it might have 16 different versions of the same library for 16 different applications. And if we do it with containers, it's actually really easy to track that and manage it.
Yeah.
Overall, the whole deal with containers as like this thing that you run is that it's and this is one of the things that isn't happening. Like containers are supposed to get us to treat to be having short-lived jails, short-lived machines. So a container is kind of a lightweight virtual machine,
right.
And the idea is the virtual machine's then not supposed to live very long. If a patch comes out, you blow away the container. You create a new version of the container image with that patch, and you quickly stand down your old ones and stand up your new ones. And it's really easy. And the technology, like Kubernetes, and even Docker with a different orchestration system, like makes that really, really easy. But I've talked to some people who are running public clouds, and one thing they say, I'm like, hey, are you finding container lifetimes to be like 1 day or 1 hour or 2 days, the way that, or are you finding people are using them like virtual machines, where it's like that thing's up and it's been up for 2 years,
right.
Or 6 months, whatever. And what people say is, it turns out something like 80% of the people using containers in the public clouds are still just doing the same old thing. Like eventually they'll get there, but right now they've got a container. That container is 8 months old and it's full of vulnerabilities, and it's not being replaced quickly.
Right.
And that's a downer because when it's discouraging, and I think it's just a learning curve thing that people are running really old. People are running a really old, a 1 month old container is generally thought to be a pretty damn old container. It's supposed
I
to
don't think it's a learning curve. I think it's human nature.
Yeah.
You have that, right?
Well, they think it's a VM. It's just an extension of a VM. It's not necessarily, something that's supposed to be blown away on a regular basis. I mean, we don't set up new VMs on a regular basis, so they just assume that it's, the exact same thing. So, it would also go towards like, communication about, this needs to be updated because these vulnerabilities are there. So, it should be fairly seamless. They shouldn't see any, if everything's architected correctly, there should not be any notice that you're on a brand new container. You should have your load balancer with like 4 or 5, containers behind it. And then like, we just, wiped away 4 of the 5, no degradation of loss. And you've got 4 new ones up and running. And then we're going to blow away the 5th one and put the new one on. If everything's architected correctly, you don't even know you're running containers, or you shouldn't know you're running container.
It's pretty crazy. It's one of those, I think it is a little bit of, maybe you're right, Mr. Besher. It's a bit of changing changing mindset and starting a new way from the beginning. And that's a little hard. I think it's a little difficult, but if you architect that way, it's a really neat idea. So I think that's it's the and I think the cool thing is that as the orchestration frameworks keep getting more and more popular, that becomes more and more easy, because if people understand what they're going to be, how those design patterns work from the beginning, they're ready for it. And so it's like, we're we want to go from version 1.3 to 1.4. That means we create a new container image, and 1.3 is running, and we basically say, okay, bring up some 1.4s. Okay, transfer the network traffic to the 1.4s from the 1.3s. Leave the 1.3s running. They're just not getting any of the traffic. And now the 1.4s are working. And if that didn't work, if there was a bug in 1.4, you just pass the traffic back over to 1.3 and take those 1.4s down. And it's a really neat thing when they do it. And I think that the really, really big shops are doing it because they had to. And it's kind of like they couldn't keep up with the level of scalability you have to do without doing this kind of thing. But until it's more painful to not go to the new model than to go to the new model, I think there's more resistance.
Right. So what kind of orchestration pipelines are out there? Are we talking like things like Jenkins or, things that what kind of tools are out there for folks that are orchestrating containers? Because it's obviously not just using Docker. There's got to be something there that says, okay, this is a good build. We're already testing. We tested this. This is good to go. We're going to make containers of it now. But what is actually being used to automate the process of pushing those out? And how do you secure those? Because all this is going to come down to how do you secure your containers but there's got to be stuff before that, right?
Yeah, sure. So first, so people talk a whole bunch about Docker, and Docker is basically that thing they call a container runtime. And there are a bunch of them. OpenVZ was one of the first. Actually, I think that the OpenVZ people basically created the container technology in the Linux kernel back in 2005. And there have been a whole bunch of others, a whole bunch of other container runtimes. Another one people have heard about a lot is Rocket. Docker is by far the most popular. But those basically let you start up containers and let you tear them down and all that. But then when you want to say, okay, well, how do I do a lot more? How do I do all of the things I want to do to basically stage work and choose which machines to tell Docker to start things on and so on? You get into the orchestration systems. Mm-hmm. Kubernetes is the one that's really kind of taking the world by storm. Because it's just got a ton of buzz, and it's pretty darn cool. But there are others, like you've got Docker Swarm is Docker's version of that,
right?
And there are a bunch of other orchestration engines. But then there's a whole bunch of stuff to do. Like there's also Apache Mesos. There are a number of these they're all trying to do this, but you still have a whole pile of things to do. And this is all, I want to say in a lot of ways that this stuff is really, really new. Like I'm blown away as I watch each of those orchestration systems. I'm kind of blown away at what they still have left to do, what they've done so far, and what they have left to do. I mean, it's on the Kubernetes side, the role-based access control. Is just just started to get easy like 2 releases ago, and until then it was kind of like it was similar to what we say if you're running on Docker. If you've given someone access, if you've got a Docker host and you've given you put somebody you put someone's user in the Docker group, they have root on the system. They can do anything they want in Docker. And that includes spinning up a root level container that mounts the file system of the host. So it's, but so these orchestration systems they're maturing. I mean, they're getting a lot more mature than they were a year ago. And that's partly a way of saying that a year ago they weren't all that mature, and they've been in use. I mean, I don't want to say everyone's moving to them, but many, many people are moving technology to them in a hurry because they're bringing a lot of capability. And the security part is definitely, it's not an afterthought, but but the security people who are developing security for these things are, they are also developers on an active project. And so it's not like everyone else is going to stop doing whatever they're doing until the security people all have something that's really, really mature and trained all the users and so on and so on. But yeah, so there's the cool thing with all of it is that when it comes to, I mean, I was around when Linux distributions were just starting to become, something that they could sell to enterprises and so on. And the Linux distros were nowhere near, like, they had to mature a lot in security. And the, Docker, Kubernetes, and so on, they're starting out like years ahead. They're still catching up now, but it's like they're starting out years ahead where the base level is more mature. The defaults are getting better and better, and they're doing it a lot faster than it took Linux distributions to do it. I don't know if I'm hoping that this is interesting and useful.
Yeah.
And if it's not, maybe I can tell you something it is.
Yeah. So there's the idea is that all of these containers run on the back of a specific Linux distribution, which most people use one called Alpine. Is it necessary to run on Alpine? And if you run on something like, I don't know, something like, the latest Debian or whatever that uses systemd, how does that affect using containers in this case? Does the container actually incorporate the systemd stuff, or is the systemd stuff part of the kernel that is sharing the rest of the containers?
Yeah, interesting. Okay, so good question. So you pick whatever distribution, like the distribution that people run on when they're running this, in an enterprise and large businesses, it tends to be whatever they had a lot of comfort with, and sometimes whatever they had support conflicts with. So I'm honestly seeing a whole lot of people running, Docker and Kubernetes on Red Hat Enterprise,
Really?
or on SUSE Linux Enterprise. And then, of course, a good number on Debian and Ubuntu.
Right.
It's kind of, so when you start a container, there's not a systemd in there. The systemd is outside. You actually could have systemd do what Docker's doing for you. You could tell systemd to instruct the kernel to set up the container for you. People don't tend to, but could. Inside the container, you generally have just like 1 or 2 or 5 programs, but it's a small number of programs per container, and it's pretty neat. There's the containers bring a whole bunch of other kinds of things to think about. Like, one of the kinds of things is, we were talking about, like, the theory is you have a container, it ends, there's vulnerable code in there, so you blow away the container and you start from scratch.
Right.
You create a new container. The question is kind of like, well, how are you going to figure out whether you've got vulnerable code or which containers need to be patched and so on? And that's become a whole different thing. You don't tend to point Nessus at a container and let it say SSH in the container, because most containers aren't running an SSH daemon.
Right.
So it's cool. You end up basically doing something different. Like, there are a couple different projects. One of them is CoreOS made something called Clair that basically does vulnerability scanning on your images, and AWS has something for that as well. And it's kind of, you scan the images and you try to figure out which ones have vulnerable software in there.
Right.
And that is kind of that was a new challenge, and it's also a pretty interesting one. But there's a ton of things you can do to make your containers more secure. It's you harden them, but you harden them kind of in a slightly different way than you just harden the operating system. But the containers actually give you a whole bunch of things you can do that make your job a heck of a lot easier. Like, one example is when you run a program in a container, you could have that, like, there's software out there that runs as root, right? And often when it runs as root just for one thing, just so it can bind to a port below 1024.
Mm-hmm.
And you could either basically start the container and tell the container to run not as a root user, but as some other user, and then remap the ports. Or you can have something running as a root user, but you strip away all of root special powers except for the ability to bind to that low numbered port, and that's called capability dropping.
Right.
There's like it's actually, I'm kind of blown away because I've been on client systems where they're not using SELinux or AppArmor on the system, but their containers are using SELinux or AppArmor profiles. Because while the admins weren't that comfortable with running SELinux or AppArmor on the system itself, or having those be in a kind of an enforcing perspective, in the container, since the container was so simple, it was just running that one program, and it's really easy to tear them down and build new ones and so on and modify. The developers and sometimes the sysadmins were comfortable saying, okay, that container is going to have an AppArmor or an SELinux profile assigned to it, and that'll be the one thing that is.
How does that work if the parent isn't as secured as the container? Doesn't that open up issues with security?
That's a little weird. The parent, so you can put a profile, you can put like an AppArmor or an SELinux profile on the container, without doing anything to the rest of the system. And what you'll get is that in the container, you'll have something that's tightly controlled. And then the container's ability to interfere with the rest of the system will be tightly controlled. Somebody who compromises that host the container is running on, yeah, they'll probably find themselves able to circumvent. What's the word I'm looking for?
Circumvent.
They'll find themselves able to get around AppArmor or SELinux potentially,
right?
Because they'll probably be running in a pretty unconfined, in a very loose situation. But the idea is that most of the attack surface for the system itself is supposed to primarily be, the idea is the attack surface are the programs running on it. If those programs are in containers and those are confined by SELinux or by AppArmor, then you've made things much, much better.
Right.
Because it's all about threat modeling at the end of the day, figuring out what part of the threat model are you going to actually try to do something about.
Right.
And ideally be like, well, all of it, of course, but that's not really I think in a lot of ways, the whole point of threat modeling is to figure out where we're going to spend our time, because our time's limited.
Yeah. So I'm going to go to something that I know will interest Mr. Betcher quite a bit with regards to logging and monitoring of containers, because obviously you're running a specific service or a specific item inside a container, and this must be a nightmare for people monitoring these things, because one, containers don't last long. So if you have a box that's doing all kinds of nasty stuff, and then all of a sudden it gets blown away, your trail of evidence is going to go cold fairly quickly. So how do you monitor these? How do you make it so that when you put it in your SIM Yes, we will kick you off in about 10 minutes, sir. Yes, we have no, that's fine. We can definitely manage your wife's expectations, because we don't want Mrs. Beale to get unhappy at us. So, so this, the last thing, of course, is the logging. So how would you monitor or do this so that the evidence doesn't come up cold if say you've been hacked and they're using those as a method to, attack or to get into your network?
Yeah, the idea is that you end up. The idea is that your logging is being is all the logs from the container are being managed somewhere else, and
right.
that's a strength. That means your attacker similar to what we did old school back in the day, where all the systems were logging centrally, meant that your attacker, unless they could get to that central system, wasn't able to wipe the logs the way they used to. So containers kind of by default don't have their own logging system. So their logs have to go somewhere else. There's the usual thing whether you call that, the usual thing in the The usual thing for the people with budget is Splunk, and the usual thing for the people without budget is Elk. But you get those. But you basically, it's not just it's best practice to get logs off the system, to not log locally. It's basically that's what you're doing anyway, like it or not. Mm-hmm. And part of the reason for that is the containers are specifically not supposed to live long. They're supposed to be replaceable.
Right.
Like the whole model on containers, I got into this not for this business case, but just because I'm thinking like, okay, I'm locking down Linux systems. What I'd like to do is take programs that might get compromised and stick them in a container, and then use some cool technologies to make those containers like a much tighter fit around a much tighter jail around the program. I'd like to make it so that program is, something I can do with a container that I couldn't do unless I was modifying the source code normally, is like limiting all the system calls, all the things that the program does. Like whenever a program reads a file or writes a file or does kind of anything that it needs the kernel to do, it uses a system call. And if you stick a program in a container, you can basically say only these system calls are allowed. The others aren't. So, and that means that, your attack surface is, what a program can, first the kernel attack surface is reduced, but what a program can do is reduced. And that's a lot of what hardening is taking the program and saying, okay, what does it normally do? Okay, it normally does this. I'll call that a behavior profile. Can I confine it to that behavior profile so that if somebody does find a vulnerability in that program and they now are turning that program into their own shell, can I make it so that shell doesn't work? Or can I make it so that their control of that program is either broken or far less useful?
Right.
So I think I've gone non sequitur on you here.
That's okay.
I apologize,
But so what would be the worst thing to be happen? Somebody gain access to the container server so they could push out their own root level containers that would allow them to make, connections out, or? Oh yeah, that's a good question. So the worst case scenarios, what are people actually big time worried about with container security? There are a few. One is that if you can get your hostile container running on a system, it is likely going to be able to, unless the system's well locked down against this, it's likely going to be able to attack other programs on that system or attack the system at large in a way that wasn't so doable. If the thing's running as root, I'm not going to say it's game over, but it's rough. If it's a privileged container, so you go for unprivileged. What are the other ones? Well, if I get my container onto a system and I'm able to see the kind of the secrets that the other containers on the system might have, whether that's TLS, call it SSL keys, private keys, or what have you. Another is network access. If I can get a hostile container onto the system, can I attack a cluster? Can I attack the internal network? Somewhat similar to the world pre-container. Right.
Yeah.
Well, I mean, when you got something on, a system before, it'd be an executable, which could be arguably some of these containers can be as small as 8 meg. So you can do quite a bit of damage with an 8 meg file or an 8 meg container in this case. That makes complete sense. So
yeah, I mean, at the end of the day, a lot of if you look at a lot of the hardening that you do on container systems, on Docker or on Kubernetes or what have you, a lot of it is basically saying, okay, I need to figure out how do I make sure that if I have a hostile person who has either is allowed to deploy their own containers that they can't interfere with or attack the other containers or the host system or the network it's on. Whether that network is a real network or it's an Amazon VPC or what have you. The other biggie is basically saying, can I make sure that someone who's either in a container or has access to the cluster, can't. What am I trying to say? Sorry, it's the sleep. It's the new baby sleep deprivation.
Yep.
I'm trying to make sure that someone who either compromises a container or is allowed to put new containers on a cluster, either of those, that they can't screw it up for everybody else, that they can't get to the stuff that's more valuable or the stuff that belongs to somebody else or whatever. It's just trying to do that containment. And some of this is pretty new to these systems. I mean, so Kubernetes has had role-based access control. That's the biggie on Kubernetes. That's one of the, and they've had network policy where you can set an egress firewalls out of containers or out of pods. But those only have gotten easy to use in the last couple of releases. I actually do want to say something. If you're on Kubernetes, if you're listening to this and your organization runs Kubernetes and you're wondering what's the biggest, most powerful thing you can do for security, the first and foremost one is if you're on a version, it's upgrading your version of Kubernetes. If you're on a version before 1.8, there's a whole bunch of security features that either you don't have, or the defaults are very weak, or the security features you have but they're really hard to use, and they got a whole lot better. And that's the one. If you said, okay, we're running an elevator, what's the one thing I should do for my Kubernetes system? I basically say, if it's any older than 1.8, get it upgraded, and then track upgrades, because the Kubernetes developers are doing great things for security, and a lot of it's happened really recently.
Very cool. Okay. All right. Well, I know Ms. Beale wants you off by 8:00 Pacific, so we're going to go ahead and give you 5 minutes of variance on that, so you can get out and see her. Jay, I appreciate it. Yeah. So we appreciate you coming on. How would people get a hold of you if they wanted to? Maybe talk about the class you're going to be doing at Black Hat, and how would they reach out to you if they wanted to discuss more on container security?
Yeah, good question. So look for me online. I'm Jay Beale, and the big ones are Twitter. So at InGuardians is the company that I'm one of the co-founders of, and we do a lot of cool stuff in Linux and in Windows, and we're a security firm. And so watching Guardian's Twitter and then my own Twitter, JayBeale, Jay Beale. Both of those, generally I do blog posts, webinars, and all kinds of stuff. And if you watch those two Twitter handles, you'll see a lot. And honestly, if you follow the InGuardians Twitter handle, you'll see interesting stuff from other people who are doing much cooler things than I do.
Awesome. Okay. Well, we'll let you go. We're going to finish we're just going to say our good nights. And you're always welcome to come back on, Jay, if you want to talk about anything else. And good luck on your class at Black Hat and DEF CON. And if I don't see you at CSEC East, before the next time I see you, then, it's been a pleasure.
Thank you very much. Hopefully I'll see you at CSEC East soon. I really should make it out, and maybe I'll even get to bring a baby soon.
Yes, please do. We need another mascot. So, yeah.
Okay.
Yeah. All right.
Cool.
Good night.
Thanks a lot.
Yep.
Bye.
Bye.
So, Ms. Berlin, did you have any closing thoughts or anything like that?
No, that was a lot of information.
Yes, I'm going to have to go back and listen to this myself because, containers, it just seems like that's one of those things that people think it's cool to use because it's going to save us so much money. But of course, like most new technologies, they don't take the time to secure it or to understand. They understand 10%, just enough to get started. But the rest,
that's all I know about containers is definitely 10 or less percent.
Yeah, my thing is, it's like
I ran one once. That's it.
Yeah. See, I have Docker installed on my MacBook, and I actually have it installed over in my lab, but I don't do anything with it. I don't run applications, or I don't need one Apache web server or one Nginx box running, what I'd love to do is maybe find some deliberate, I know that there's some websites out there for like deliberately vulnerable containers or something like that. I'll have to find that. I don't know if I'll be able to put it in the show notes, but I know there's something out there about that where you can go in and poke around on, deliberately vulnerable containers and understand the security model behind that. So, Mr. Betcher, what did you think about the logging and stuff? Because I mean, from a logging point of view, I know you're mostly Windows, but I mean, both of you do SIM and logging, together. But it seems to me that things that you would want to log on would be, if there's a way that you can say, okay, this instance or this Docker container was stood up and it's a root based. It's got root on it or something, or it's a, privileged container is what he called it. I would think you'd want to alarm, because you're not normally supposed to run things as, with those kinds of privileges. So that would be something you'd want to alert for, I would imagine.
You got it. You'd want to alert on that. And you'd also want to log when these containers were spun up, what kind of privileges or access they have. And you want to concentrate on the underlying application, what it's doing. So application logging is important. So get those application logs out and into your central SIEM or your host machine. That way you know what's going on in your app and you don't lose that. So if somebody logged in from some country you don't do business in and doing things you don't approve of, you got that log in your SIEM or whatever. And then if that container goes away, that's okay. You still have some history there.
System owners seem to be like another thing you'd want to log, like, Bob stood this up at, whatever time. And, is Bob supposed to be allowed to set up containers or, did, so yeah, that makes sense. So, so did you just highlight that now? Somebody highlighted the difference between sandboxes and containers.
Oh, I did, but that was like 15 minutes ago. So I wanted to ask Jay that question. And I was thinking, we had a podcast where we talked about, or a couple of them, about sandboxing, right? Because browsers are a huge vector.
Sure.
Can we containerize our browsers? Would that be a good use for them? Just spin up your container on your, everyday laptop that has your browser on it, and then take it down.
I think the new Microsoft Edge browser is already running in a sandbox, or at least the app, the plugins itself run in a sandbox. So Microsoft does have a bug bounty program for vulnerabilities in the latest Windows 10 Edge browser. If you can pop outside of the sandbox, then you get $100,000 or something. I think they did that just recently. I want to say Chrome has a very similar type of sandbox environment. Please let us know if we're incorrect on this. But I think that they do have that. I think the difference really between containers and sandboxing is containers are more OS level versus sandboxing, which would be versus application. Sandboxing would be per application, because you don't have all the sandbox, like sandboxing you're talking about, runs on top of an OS. So, and it runs applications specifically, right?
Yeah.
So it'd be an application level container, if you will, or something that's isolated and doesn't allow things to talk outside. That would be my guess. That's what I understand. So, all right. So, let me see. I don't have anything else. I mean, if anybody else has any other thoughts, questions, suggestions.
That's all I had.
Cool. All right. I'll take y'all's silence and as affirmation that we're good to go. Ms. Berlin, are you going to be speaking or doing anything in the near future? And how would people get a hold of you if they wanted to talk to you about, applications and sandboxing and containers?
That is a great question. I think next for me is Converge Detroit. I'm keynoting there on May 10th.
I'm just keynoting again. Oh, God, it just really sucks. I have to keynote again. So,
it's only my third one. I'm not tired of it yet. I just started.
You have to start charging.
I know, right?
I have a lot of people already pay for my travel. That's good enough.
Nice. So, how would people get a hold of you if they wanted to?
On Twitter or our Slack group at InfoSister. INFOSYSTIR.
Excellent. Mr. Betcher, I know, the LogMD is going gangbusters. How would people get a hold of you if they wanted to talk about, logging of containers and how they should go about doing that, or, LogMD in particular?
We have a lot of ways. First of all, on our Slack, on the BDS Slack channel, I'm a regular on there. It seems. Yes, regularly irregular. But yeah, just hit me up on there, or you can hit me up on Twitter. My handle is @BetcherPwned, BOETTCHERPWNED. And also, if you can't get any of those, just hit me up on email, or you can find that on log-md.com.
Cool. All right. So, the BreakSec podcast is @BreakSec on Twitter, BRAKESEC, and you can follow me, Brian Break, @BrianBreak on Twitter, BRYANBRAKE. I'm not cool enough to have like a hacker name. I wish I did, but
we'll get you one. We'll get you one eventually.
No, let's not, because it's probably going to be very unflattering and hurt my feelings. So, yeah. Like, Captain Goofy or something like that. I don't want to be Captain Goofy. Yeah. So our Slack, we do have a Slack. We are very active on there. It's become a community of its own. If you want to join us, you can email us for an invite at bds.podcast@gmail.com, or you can DM us on Twitter @BreakSec, and we'll get you an invite out to that. So I will be besides Springfield, Missouri, where I am going to be giving the first talk of the day. I don't know if I can call it a keynote or not. Maybe they will let me call it a keynote. I'm not sure, but
I would if I were you.
Okay, so I'll be giving, right after the opening remarks, I will be giving the first talk of the day, or keynoting. We're going to be talking about community and building communities, building proper communities. And that's on July 14th. And the link to tickets will be in the show notes if you want to go. They still, as of the 22nd of April, when we're recording this, they had over 100 tickets available. So they just opened it a couple days ago. So there's still time if you want to go to Springfield, Missouri and watch it. It is the largest city in the country named Springfield. So we checked that out before the show. So the podcast, you can find it on Apple Podcasts, Google Play Store, TuneIn Radio, Spotify. All of the links for those are in the show notes. We have an RSS feed if you just want to do it up old school. And we have a Patreon if you find value in the podcast you just heard with Mr. Beale. We do believe in the value for value model, so please feel free to leave us a couple of bucks. It's always well, what's that word I'm trying to say? Well received and much appreciated. So, and that goes towards hosting fees for the show and equipment upgrades and maybe some swag. We're looking at swag. So for DerbyCon and stuff. So, and stuff that you can get for being a listener. So we appreciate all of our Patreon people over there. So that's all I got. I didn't forget anything, did I? Patreon. Spotify,
class.
Class. Professor Miller's class is going gangbusters. We're finishing up with session 4 of the assembly course. So the remaining 4 classes we have are on the reverse engineering. So if you just wanted to learn more about reverse engineering and you've named your firstborn EAX and you don't need to understand assembly anymore, there's still time to sign up for that one. So it's $150 if you want to sign up. It's 4 sessions. A lot of great feedback coming out of the class right now. And if you want to learn anything about Binary Ninja, that's what Professor Miller teaches. So please feel free to get involved on that. So we will make the videos public and available to World Plus Dog probably end of June, I think. That would probably be the best time. So, So if you can't make the classes, then, we'll give the training away in the next few months. But we do have some folks who ask for early access to the videos. So we want to make sure that they get that content just a little bit before the rest of the world. So, All right, so that's it. That's all I've got for breaking down security. Mr. Betcher, Ms. Berlin, have a great week. I appreciate you too. You know that. So you appreciate me, right?
I did. I was sorry. I was holding in a sneeze.
Is that what it was?
I appreciate you as well.
Okay, good. All right. I
I
noticed.
love you guys.
I love you too.
I love you guys.
I love you guys. All right, so that was it for breaking down security. Everyone have a great week. Be nice to one another, and we'll talk to you again real soon.
Bye-bye.
Bye.